Today we're going to do B2 investigation, predicting speed. Our focus essential question is how can you predict outcomes based on scientific models and investigations, and how does speed and acceleration affect an object's motion. Take a minute, look at our end goals or end learning targets. It's 1.1, being able to develop and evaluate a controlled experiment once again, and 1.3 of being able to distinguish between speed, velocity, and acceleration. Today we're actually going to start to explain speed's relationship to an object's motion. Take a couple seconds, pause the video, and read the following description. The biggest thing here is models. Models are graphs or equations. They can accurately predict our speeds. Models are important to science. Predictions that are tested by this experiment should be found within 5% of accuracy. All right, when you develop and achieve this kind of accuracy, you will develop confidence with your science, and you will then be able to explain speed graphically and with an equation. Take a couple minutes and read this and pause the video. Instantaneous speed is different than the speed that you calculated in B1. You calculated average speed. Instantaneous speed is the speed at one particular moment. But we need a time over which an object travels that certain distance. So we won't be able to calculate exactly instantaneous speed, but pretty close. We're going to be practicing the speed or calculating the speed of when the car wing breaks the photo gate to pass through it. So that's going to be the 5 centimeters. Our distance, ladies and gentlemen, is always 5 centimeters. Now, you'll start to develop the concept of acceleration. Acceleration is the rate at which an object's speed changes. However, what in the world? However, you will not actually calculate the acceleration. We'll deal with that in B4 or 2 more investigations from now. So go back, review what this investigation is about, and then go make a copy. Now, if you forget how to make a copy, all we have to do is go to our Google Docs account. Click on your science folder. Now remember, it's in the collection shared with me. That's the collection shared with me. Go to Unit 1 Motion Documents. Click on B2 Investigation Student Copy. It will be purple. Then we go to File in our Google Docs. File. Make a copy. Click OK. Remember, we can name it anything we want. I would just keep it Motion B2 Investigation. Click OK. And then make sure you drag this into your own folder. So the purpose question of today is, can you predict the speed of a car at any point on the ramp? Read the introductory paragraph, and let's go down, and I really need to focus on the procedure for you guys. You're going to select 7 locations. Alright? Those have already been predetermined for you. That is the position, not the distance, the position of the photo gate. At each of the locations, record the position of the photo gate and the time of the photo gate. And the distance traveled will be the same for every position because it is the width of the wing, the width of the ring. Then calculate the speed using the width, which is 5 centimeters. And record this. So here's our data table. Here's the time and the speed. You're going to have to remember your speed equation, and the distance will always be 5 centimeters. Answer question 2.1 and then 2.2. Make sure you click on your period's data table and graph. If we click on that, you'll notice that we go to a new spreadsheet. This is where you put in your speed of the cart. It will automatically graph for you, but once you start graphing these, for example, let's just put 34, 35, 36, 37, 38, or 8. 50, 60, 36, 37, 38, 39, 40. Click on the graph, click on this button right here, and edit your chart, customize it, and make sure you make a title and label the axes, alright? If it's the horizontal or the left vertical. Make sure you label them correctly based on your data that you've been given. Okay? Have a great day. Make sure you pay attention and be respectful to the sub. Thanks.